This is a presentation on bivariate distribution or the joint distribution of two random variables. So let x and y be two random variables on the same probability space. Then together xy as a vector is known as a two-dimensional random variable, and this is a vector valued function. And how this will be defined? So this will be a mapping from the same sample space S to R2, the two-dimensional Euclidean space. And how this mapping will work, that for every w in S, xyw will be xw comma yw. So for every element of the sample space, it will assign a pair of real numbers xw and yw. For instance, x could be height, y could be weight, or x could be the score of an individual before taking a tutorial, and y could be the score after taking the tutorial. So in this way, xw, yw will then represent the height and weight or the scores before and after for each individual. So now we are looking at the probability distribution of this random vector xy. Now this is essentially a probability statement involving the two random variable x and y. So here we are interested in computing the probability that xy together belongs to a set C, where C is any Borel subset of R2. Borel subset means it is a member of the Borel sigma algebra, and that you have studied in analysis. That is the collection that is generated by open intervals. In this case, in R2 the intervals means rectangles. So I will not get into all that, but just for the sake of correctness, I have mentioned this Borel subset here. But basically, so we are concerned about probability distribution involving two random variables where xy are in some set C, where C is a subset or a part of the two-dimensional plane or the two-dimensional Euclidean space. So some examples of C I have written here. So it could be the points xy where x greater than y. That means, or it could be the points xy where x equal to y. So the second one, is very easy to understand. What is this C? This is the points on a straight line passing through the origin and x equal to y. So that is the 45-degree line. And this first one where x is greater than y. So these are the points below this straight line x equal to y. So the x coordinate is bigger than the y coordinate. And similarly, C could be a Cartesian product of two intervals. So you know what is a Cartesian product of two sets. So this will be the collection of points xy where x is between a to b and y is between c to d. So in this way we can have different choices of C. Now if you recall, what was a one-dimensional probability distribution or probability distribution of one random variable? It was just such a probability statement but involving one random variable x or y at one at a time, and in that case that C would not be a subset of R2 but it would be a subset of R1. So here in general I am writing if C in particular. So although we are concerned about any Borel subset of R2, in particular in practice, if you can define these sets for C equal to A cross B, then it is sufficient for all practical purposes. So if I take C is equal to A cross B, where A and B are two Borel sets of real numbers, then this C would reduce to probability x equal to A and y equal to B. So this comma is actually an intersection. So this is a joint statement about x and y. So from this joint, since this is a joint statement about x and y, and so therefore this distribution is called the joint distribution. So the word joint distribution is coming from this intersection notion. Now in this case it is clearly visible that here we are talking about two events, x in A and y in B. So if we simply look at the probability of x in A being silent about y, then that is called the marginal probability of x. And similarly, if I talk about the probability of y in B being silent about x, then that is called the marginal probability of y. Now if I know the joint probabilities, then from there I can find out the marginal probabilities like this. So when you are interested in finding out probability x in A, but you know all these, so you simply take b equal to r. That means you are considering all the values of y. Similarly, when you are interested in finding probability y in b, then this is probability of x in r, y in b. Why? Because when you say that y y is taking values in the set b, and you are silent about x, so you mean that you are considering all the values of x. So for every value of x, you are looking at the corresponding value of y, whether it is in b or not. So these, I am leaving these exercises for you. You have to think about these answers. Now, just to give you a hint, so if you are interested in finding what is this event in terms of this set S, ultimately I have told you that both x and y are random variables on this same sample space. So x in R and y in R, what do they represent in terms of this S? That is the hints. Now, in general, if you are trying to find out the joint, if you know all these joint probabilities, as I said that the marginal probabilities can be obtained by these formulae, but the converse is not always easy. That is, even if you know what is probability x in A and y in B for all choices of A and B, that is, you know the probability distribution of x and y, still from there it is not easy to, not always possible to construct the joint probabilities, unless of course you assume something called independence. So two random variable x and y are said to be independent if and only if if stands for if and only if, so the joint probability is the product of the marginal probabilities. So that is the definition of independence, and if that happens, then you know that expectation of x and y is equal to x into y is equal to expectation of x into expectation of y. So joint probability and joint density function. Now we can make the idea of joint distribution is even more specific. Suppose x and y are two discrete random variables, that is both x and y take countably many values with probability 1, then we can talk about joint probabilities, like probability taking the value x equal to x and y equal to y. So this is called the joint PMF, and when in that case these joint probabilities, that is probability x and y, are in C. So these are the sum of those points in C. Then you sum over probability x equal to y and y equal to y, so over those points which are in C. You are not concerned about points which are outside C. Similarly, if x and y are two continuous random variables, and let f be a non-negative valued function of two variables, such that you compute these probabilities integrating f over C, then you call f the density function, joint density function, because you are computing the joint probabilities by integrating this function of two variables. Now, and this is a small question, what do you think will happen if I remove this restriction, if I just integrate over all the values of x and y? So this will be the same thing as probability x in R, y in R. So that would be the unrestricted integral of f over all values of x and y. Then here is an example how this is used. This concept is used, that suppose x and y denote the score or the response of an individual to a set of questions before and after attending a tutorial. What is the probability that the score will improve after attending this tutorial? So what you are really asking is, the score after the tutorial is bigger than the score before the tutorial, so probability x is less than y. So in this case, so you are interested in a joint probability that xy is in C, so x denotes the score and before, and y denotes the score after the tutorial. And what is this set C here? C is the set of points where the first coordinate is less than second coordinate. So if you imagine the line, 45-degree line passing through the origin, and so we are looking at points above it. Now in this we can be slightly more specific, that how would you compute this integral? So you let y vary over all possible values, but you will consider only those values of x which are up to y, not exceeding y. So in case x and y are discrete, so these integrals will be replaced by summations, and the density will be replaced by PMF. So then in that case it will be sum over all possible values of y, but the second summation, that is the summation over the values of x, will include only those values up to but not exceeding y. So today I have given you some a bird's eye view or an overview. Then I will give you specific problems to solve using these concepts. Thank you.